All right, so now we're looking at the tortoise and the hare. The tortoise and the hare. Have the tortoise and hare complete a race of X units long. The user will decide on the length of the race. You should decide what a minimum race length should be. Use a random number to determine the distance each travels per unit time. And each term display the current position of both the tortoise and the hare. All right, I'm going to actually solve it two ways. The first one, we're going to need to ask. So we're going to have a couple of variables. We're going to have the tortoise. I spelled tortoise. Y there, I don't think. Tortoise and hare. Number of turns. And I guess that's actually sort of the distance, not number of turns. That would sort of be the distance, how far. Rename variable to distance. All right, so we're going to start off by asking the user how far they want the race to be. So it's an input. How far do you want the race? Minimum 30. Okay, and I'm going to assign that to the distance. So is that a math? Set it equal to something? No, is it a statement? Logic. That's testing. Oh, so it sets variables. All right, so I'm going to set distance equal to the input statement. Now this has got to be an integer value because I'm going to do some math with that. So take the integer value of that. So I want an integer value for the length of the race. Once that's done, I'm going to have to, I don't know how many times I'm going to have to do this because it's going to be dependent upon how far each character goes. So we got to say while, it's going to be a while statement. It's going to be a loop and say, I don't know exactly how many times this will happen. So it's going to be a conditional until the race is over. So I might just go with while true for now. And once I know how far the race is, I'm going to have to generate a random number for each character that will say how far they go. So let's say they can go a distance of between 1 to 3 units each time. So let's set our variables for both the hare and the tortoise. Let's set them at the very beginning to be 0. That's how, because they're starting at the finish line. So they both start at the finish line. And then I'm going to generate a random number and add it to their distance. So now I can say that the the hare's distance is going to increase by a random value, random integer of between 1 and 3. And the tortoise's distance is going to increase by the same amount. I wonder if I can just duplicate this. Duplicate. And the tortoise will increase by a random value of between 1 and 3. Then I need to check to see if either the hare or the tortoise is greater than the distance that's been traveled. So logic statement, if let's do a check to see if both the hare and tortoise pass in the last lap, in the last leg, then we'll say it's a tie. So if, is there an and? So if the hare is greater than 100, this logic again. Great. So we can say if the hare is greater than or equal to our distance, and if the tortoise is greater than or equal to our distance, that means I've just added their random values. Suppose our minimum race length was 30. The hare is at 28 and the tortoise is at 29. The hare gets a random number of 3 that would move it up to 31, and the tortoise gets a random number of 1 that moves it up to 30. They are both at the finish line in the last turn, so I'm going to call that one a tie. You could just say instead, you could check to see whoever went further. If in the last race, in the last part, someone reaches 30 and the one reaches 31, you can make the argument that the one that got to 31 is the winner. You can decide how that's done, but I'm going to set up my conditions like so. So I'm going to make a statement. Oops. Statements, I need a print statement. It's a tie. Else if, so this is if both of them are greater than distance. If only one of them is greater than distance, else if the hare is greater than 30, but the tortoise isn't, then this will execute. Then that must mean that the hare won. And now it's possible that the hare is not greater than distance, but the tortoise is. So that's another else if statement, elif. Elif the tortoise is greater. Oops. If the tortoise is greater than or equal to the distance, then that must mean the tortoise won. And if none of them are over the finish line, that would be else. That's the only other option. Else, we need to print their current locations. So I'll say print and this is where I like putting in, I like to be able to put words and variables in the same line. So I'm going to put in my own code. I'll put in my own print statement. Whoops. Else print the hare is at, and I'll put hare but printable, or the hare variable, and the tortoise is, whoops, and the tortoise is at, put in the tortoise variable. So, oh, and this is going to keep going on forever, right? It'll come back up and add more things. But of course, if one of them is 1, then we need to break out of that loop. So is there a break? There we go. I need to break out if they've won, and I need to break out if the other one won, whenever there's a winning. It'll break out the loop. And otherwise it's going to say who is at what position. And let's try running that. Line 24. Probably shouldn't be there. Oh, I didn't close my bracket. Let's try running that now. How far do you want the race? Let's go with 30. Random is not defined on line 10. Did I forget to import random? I forgot to import random. Import statements. Now let's try running it. Let's go with 30. Hare is at 3, tortoise is at 1. Hare is 6, 3, 27, 23. So not surprisingly here that the hare won. Let's run it again. Hare won again. Won again. Here we go, the tortoise won, 26, 28. I'm just wondering if we'll get a tie. Oops. Oh no. Oh no. Oh. Well, we saw that that worked. And this is an issue with creating an EduBlocks. It doesn't save like that. So we saw how it was done. That's a sample solution. I'm going to create another video for another possible solution.